Example 1, identifying the intervals of increase and decrease of a quadratic function. Math of Mr. Williams. Identify the intervals of increase and decrease for each function. Here we have f of x equals negative x squared plus 2x plus 8. All right, so the first thing we want to look for is the axis of symmetry, and we can find that right down the vertex area here. There we go. All right, and we can see right there that is going to be x equals 1. So we know all of our intervals are going to deal with 1. So we can see it is increasing on this side and is going to decrease on this side of the 1. So where it's increasing, we have x is less than 1, and where it's decreasing, we have x is greater than 1. Example 2, determine the x-intercepts of a quadratic function in factored form. Math of Mr. Williams. Determine the x-intercepts of each quadratic function in factored form. So here we have f of x equals x minus 2 and x minus 8. Okay, so to solve for those x-intercepts, we know that the x-intercepts are when the f of x value is equal to 0. So we need to set the f of x equal to 0 and solve for the x-intercepts. So now we're going to go ahead and substitute for the f of x, making it 0 equals x minus 2 and x minus 8. Now we're going to set both sides equal to it. So we're going to break this apart. I'd like to do a nice little t-chart where 0 has to be either x minus 2 or the 0 has to be equal to x minus 8. So this is just a one-step equation. We're going to add 2 to both sides, giving us 2 equals the x value. We're going to add 8 on this side, giving us 8 equals x on this value. So the x-intercepts are at the order pairs of 2, 0, and 8, 0. Example 3, determining the axis of symmetry of a parabola given the x-intercepts. Math of Mr. Williams. Determine the axis of symmetry of each parabola. The x-intercepts of the parabola are 3, 0, and 9, 0. Okay, so let's go ahead and just use this graph off to the right here. Let's go ahead and just put those points. So we have 3, 0, and we have 9, 0. And we know that no matter what, if this was a parabola that opened upward or downward, there'd have to be an axis of symmetry somewhere between those two dots, because it's the halfway point. It's like folding something in half. So to find that, what we're going to use is this formula, R1 plus R2 divided by 2. So the R1 represents the 3, and the R2 represents the 9. So we have 3 plus 9. We divide that by 2. 3 plus 9 is 12. Divide that by 2, and we end up at 6 is our axis of symmetry. If we come back over to our graph, we can see we were pretty close in our quick drawing of our axis of symmetry. Call that the axis of symmetry, AOS. It's right there at 6. Example 4, determining the vertex of a parabola given the function and the axis of symmetry. Math of Mr. Williams. So here we have f of x equals x squared plus 2x minus 15, and an axis of symmetry where x equals negative 1. So what that's telling us is that in our function, if we plugged in negative 1, we're going to figure out what our f of x is. Let's go ahead and plug our negative 1 in. So f of negative 1 equals negative 1 squared plus 2 times that negative 1 minus 15. I like to show my substitution with parentheses so I know I substituted correctly. So the first step is the exponent. Negative 1 times negative 1 will give us 1. 2 times negative 1 give us negative 2. Then we have minus 15. All right, I'm going to combine my negative numbers here with the ones dealing with subtraction. Negative 2 minus another 15 give me a 17. It's negative. Then we have 1 minus 17 equals negative 16. So the vertex is at negative 1, negative 16. Example 5, determining another point on a parabola given only the axis of symmetry and a given point. Math with Mr. Williams. So the axis of symmetry is x equals 3, and a point on the parabola is 1, 4. Let's go ahead and put that on our graph. So here's our axis of symmetry, and here's our point at 1, 4. So not knowing if our parabola is going to open upwards or downwards, we for surely know that the middle point or the halfway point of the parabola, the axis of symmetry, is going to have to go through this point. That means this could look like anything that goes through that point, but kind of goes right through that middle part as that axis. Lucky for us, we don't need to know that. But given the information we have, we know that there's equal distance on either side. So we can see here that if I'm looking at my axis of symmetry, I can count 1, 2 spaces this direction. Or if I did the math, it would be 3 minus, and our point was at 1, 4, the x value is 1, that would give me 2 spaces away from my axis of symmetry. Therefore, there has to be another point on the parabola that's the same y value, but equal distance away from that axis of symmetry. So since we went left 2 spaces, I'm going to go to the right 2 spaces, 1, 2, finding my point right here at 5, 4. And the math at this point would be, since I was at 3, I would now, instead of subtracting 2 to get back to that 1, I would just add 2 to go this direction, and I would end up with 5 for my new x value. So there is another point on the parabola at 5, 4. Example 6, general versus factored form and their key characteristics. Math of Mr. Williams. Identify the form of each quadratic function as either general form or factored form. Then state all you know about the quadratic function's key characteristics based only on the given equation of the function. So in this case, they don't want us to use Desmos. All right, we need to be able to look at it and find those really quickly, or do a little bit of math to identify those key components. So the first one, f of x equals 5x squared minus 30x plus 57, that's in general form. And next we need to decide if it's going to open upwards or if it's going to open downwards. And we can look at the a value here. The a value in this case is positive, therefore this is going to open upwards. Now what the general form also gives us is the y-intercept, and we could find that by our c value. So here we have 57, and we know that for our y-intercept as an ordered pair, the 57 is going to represent the y value, and all x values are going to be 0 if they're a y-intercept. All right, on to our second one, we have f of x equals a negative parentheses x minus 8, and then parentheses x minus 4. Okay, we see that, we know that format, that is in factored form. It does not look like the general format of it. We can tell real quick because of those parentheses, there's 2 of them there. All right, and how do we tell if it's going to open upwards or if it's going to open downwards? We look for that a value. We can see that it's up here in front, and it's a negative value. So really this is just a -1, and so since it is negative, that is going to open downward. Now what this also gives us are the x-intercepts. So what we're going to do is we're going to substitute in 0 for our y value. So we have 0 equals the negative value, I'll put a 1 here for us, x minus 8 and x minus 4. Start a quick t-chart. And since there are technically 3 things up here, right here, I'm going to show and prove it to you why the first part, that a value, really doesn't matter at this point when we're in this format. So we have, if we set 0 equal to each of these items, because if you multiply something by 0, it's got to be 0 at the end. So we have 0 equals -1. We have 0 equals x minus 8. We have 0 equals x minus 4. So we can tell right off the bat that -1 doesn't matter because 0 does not equal -1. So this is not a true statement. But on the other hand, the other 2 we can solve. They're one-step equations. So instead of subtracting 8, we're going to add 8 to both sides, giving us 8 equals the first x value. And then we're going to add 4 on both sides of this one, giving us 4 equals the other x value. So now we have our x-intercepts at 8, 0 and 4, 0.